I'm Lindsay, and I'm going to share the research that I did on influenza for our research paper. Some of the questions that I'll talk about is, what is influenza? How does it infect organisms? How does influenza mutate? What drives the evolution of influenza? And how does the evolution of influenza affect us today? Influenza has been around for thousands of years. It's commonly known as the flu. Sometimes it's mistaken with the cold, as it has the same respiratory symptoms of the runny nose and the cough. But you have the flu when you also have a fever and body aches to go with it. And every year in the US, 64 million people are infected, and 51,000 of those result in death. Influenza is part of the Orthomyxoviridae family. The different parts of this family include influenza virus A, influenza virus B, influenza virus C, thogotovirus, and ESA virus. And there's others that researchers have recently come across, but they're still doing more research on those to find more about them. So influenza is a unique microbe because it's a virus. As you can see, it's an RNA virus here, and you can see the RNA bundled up in the middle here. It's surrounded by a capsid and a lipid envelope. And then outside here, sticking out, are glycoproteins that coat the outside. And specifically, there are two types called neuraminidase and the hemagglutinin. And these two glycoproteins are probably the most defining characteristics of the virus because this is how they identify different strains of the influenza virus. Most people are familiar with the name H1N1 as a strain of the flu virus, and the H refers to the hemagglutinin, and the N refers to the neuraminidase. And then the numbers refer to the different shapes that the glycoproteins take on the outside. So there's a wide range of hosts that are infected by influenza. As you can see, it's not just humans here, but birds, pigs, horses, cattle, seals, cats, whales, and there's others that are known to carry the virus. And they all are carriers of different types of virus, but they can all have it. So influenza, since it's a virus, it is not able to replicate on its own. It requires a host cell to use its structures, since it only has so many structures inside of it. It's a very simple microbe. So as you can see here, it enters the host cell, and then it releases its RNA into the nucleus and uses the host structures to replicate the RNA and the different proteins that it needs. And then it puts it all together and it exits through budding into the host to continue to replicate and infect the host. And as that happens, the immune system of the host creates antibodies. And these antibodies detect those glycoproteins on the outside and recognize it as a virus and attack it. But every time there's a new strain of the virus or a new mutation of it inside of the person, the body has to create new antibodies to attack the virus. So this is why the mutations are harmful to the hosts, because they have to spend the time to detect the virus and to make those new antibodies for the new mutated version of the virus. So since the replication is never perfect in replicating DNA or RNA, since it replicates thousands and thousands of times. There's bound to be mistakes. And so one of those mutations is known as antigenic drift. And so this is found when there's a mutation in the hemagglutinin and the neuraminidase shapes. And so this happens, like I said, as it makes mistakes through replication. And so as you can see in the picture here, the H1N1 flu, it was really virulent here. It was a pandemic, and over time, as it's passed on through humans, it's mutated through antigenic drift, and now we have what we have know as the seasonal flu through all of those mutations. Another kind of mutation is known as antigenic shift. And so this is where the virus mutates through a change in the host species. So this is what happens usually when we see pandemics break out. They tend to be the most virulent types of influenza. And an example here in this picture, we can see that we had the flu here, and it transferred over into swine. And so it started to infect a new host in the pigs. And here's a chart. So a big example of antigenic shift is the 2009 swine flu. So this graph shows you, or this chart shows that the pandemic broke out all over the world. And that's because it was so virulent because it came from the swine. So that shift from species caused it to cause a big havoc on the human race. So what is happening to combat all of this is the World Health Organization. It builds these national influenza centers all around the world. And they each collect samples of influenza as it shows up in their part of the world. And then these samples are used to create the yearly flu vaccine. So they study the different strains that are popping up. They usually get it from the opposite hemisphere because they experience flu season at the opposite time as the other side of the hemisphere, the other side of the world. And so it just cycles through the north and the south part of the world. And so you know that those that are being infected in the southern hemisphere the next flu season, those strains are going to come up to the northern hemisphere. And this creation of medicine drives evolution because the flu is trying to evade all these new antibodies. And the more antibodies we push into our bodies through these vaccines and this medicine that we're making, the more strains are going to become more immune to those antibodies and be able to evade those easier. So something that also drives the evolution of influenza is human behavior. So just simple hygiene things such as covering our sneezes, covering our coughs, washing hands. Some people wear face masks when it's flu season, sanitizing things that people frequently touch, such as doorknobs and keyboards and phones, and getting your yearly flu vaccination are all things that can prevent the flu from spreading. Something else that has caused it to spread and evolve even more is the advancements we've had in travel. So cars allow us to travel places faster and more frequently, and planes allow us to travel internationally all around the world. And so people are traveling when they're sick, and they can quickly take the flu from the US to China, and if it's virulent enough, it can easily break out into a pandemic all around the world. And the flu actually has an incubation period of 2 to 8 days. And so, even within those days that people don't know that they're sick, they're constantly traveling for work and for vacation. And so, that flu can travel long distances very quickly, even if people don't know that they're sick. And a good example of this is the 1918 Spanish influenza. This is a really popular or well-known pandemic. It happened the last year of World War I. The living conditions caused 50 million deaths from the flu because people were living in dirty conditions. They didn't have a lot of access to taking showers or washing their hands or making sure their food was clean. And they were also living in very tight quarters. And often, since they didn't have a lot of room, those that were sick ended up sleeping near those that were healthy. And so it just caused tons of people to get the flu, and unfortunately, lots of them died. You can see here with the 2009 swine flu again. If we look back at this map, we can see that through travel, it was able to spread all around the world really fast. And so it just reminds us that we should definitely stay inside and try to get better when we feel sick. Especially because as much research as we're able to do and as much as medication is able to keep up, the next predicted pandemic is supposed to come from a strain in the avian influenza A. And so as soon as this avian flu goes through antigenic shift, it's going to infect humans and cause this great big pandemic. And scientists have done all they can and are doing all they can to prepare for this. They stock up supplies, they're continuing to do research, and they're continuing to create vaccinations that will work on the expected strains that will cause the pandemic. But we can only do what we're able to do through controlling our behavior, making sure we're following good hygiene and taking care of ourselves when we're sick, and trying to keep as little contact with others when we don't feel that well, because even though the flu has become a norm, it's constantly evolving, and it evolves so fast through these mutations and through medicine and our behavior pushing it to become stronger and evade our antibodies, that you never know when the next pandemic is going to emerge. And it's up to us to continue to do research and try to help it spread as little as possible so that we can prevent those future pandemics from breaking out. So that is the influenza virus, and that's all the research that I did.